Hi everyone! In this video, we're going to learn how to solve quadratic equations by yet another way, which is called completing the square. Now, completing the square is a process, and a lot of my students find it a little bit not difficult, but you have to definitely practice it because it is a process and it's always done exactly the same way. So let's go ahead and take a look at an example. Let's say we want to solve x squared plus 4x plus 1 is equal to 0. Now, the first step in solving a quadratic equation by completing the square is to go ahead and do what I like to call prep the problem. Okay, you want to prepare the problem. How do I prepare the problem? What I want to do is be left with x squared plus 4x on the left hand side of the equation. I'm going to leave a space and I'm going to put the other number, which is positive 1, on the other side of the equal sign. By prepping, it's basically leaving the quadratic and the linear term together on the left hand side, leaving a space. Because I have plus 1 on the left, I need to move it to the right. So I'm going to make it equal to negative 1. Once I prepped, I can actually now complete the square. This is the most important step. When you go to complete the square, you're going to have to take b divided by 2 and square it. And you might be thinking, where is this b coming from? Well, if you remember, the standard form equation of a quadratic equation is ax squared plus bx plus c is equal to 0. So the b is the number in front of the linear term. In the example we're working with, the b is going to be the number 4. So we're going to take the number 4, we're going to divide it by 2, and we're going to square it. 4 divided by 2 is 2, 2 squared is 4. What do I do with this number? I'm going to add it to both sides of the equal sign. I'm allowed to do this because since I'm adding it to both sides of the equal sign, I am keeping the equation balanced, but I'm able to quote unquote rig the problem so that now on the left hand side I have what's called a perfect square trinomial. X squared plus 4x plus 4, if I factor, what is going to multiply to give me positive 4 that's going to add to give me positive 4? That is x plus 2 times x plus 2. And I can rewrite this as x plus 2 squared. This is what is meant by a perfect square trinomial. X plus 2 times x plus 2 is just x plus 2 squared. And that's exactly what I want to get on the left-hand side of the equal sign so that then I can apply the square root property. So the third step is going to be to factor the left-hand side, which in this case is going to be x plus 2 squared is equal to, combine like terms, negative 1 plus 4 is positive 3. And now the fourth step is going to be to solve by using the square root property. So this means that I am ready to take the square root of both sides. Remember that on the left hand side, the square root and the square cancel. On the right hand side, it is plus or minus. So I'm left with x plus 2 is equal to plus or minus the square root of 3. Subtract 2 from both sides. So my final answer is x equals negative 2 plus or minus the square root of 3. And just in case you need more practice with the square root property, I do have another video which I'm going to link at the bottom in the description so that you can go ahead and check it out in case you need more practice with the square root property. Okay, let's go ahead and practice solving this quadratic equation by completing the square. Now, one of the things that I want to mention to you in solving this problem is that we have to make sure that when you complete the square, the leading coefficient a is equal to 1. Right now, a, which is this quadratic term's coefficient, is 2. It is not 1. So one of the ways that I'm going to be able to make sure that I have just x squared is to just go ahead and divide the entire equation by 2. And I'm going to end up with x squared minus 4x minus 5 over 2 is equal to 0. So now I have this as my new quadratic equation, and now I am ready to go ahead and do the steps to complete the square. If you remember, step 1 is the prep step, which means that I'm going to keep x squared minus 4x. I'm going to leave a space, but I'm going to move the 5 over 2 over to the other side. Now that I have that completed, I can come over to the side and I'm going to take b, which in this case is -4. I'm going to divide it by 2 and square it. This gives me -2 squared, which is going to equal +4. I'm going to add +4 to both sides. On the left-hand side, this is going to factor out as a perfect square trinomial. What multiplies to give me 4? That's going to add to give me -4. -2 times -2. So this becomes x minus 2 squared is equal to, on the right-hand side, we have to add this fraction to this whole number. Let's go ahead and turn 4 into 4/1. I need to change the 1 to a 2 because you cannot add two fractions unless you have the same denominator. I made the 1 a 2 by multiplying by 2. Whatever you do to the bottom, you have to do to the top, which means that the top number is going to become 8. So on the right-hand side, 5 plus 8 is going to give me 13/2. Now that I have this problem written this way, I can go ahead and use the square root property to finish solving. So I'm going to take the square root of both sides. On the left, the square root and the square cancel. On the right, I have to make sure this is plus or minus. I'm left with x minus 2 equals plus or minus the square root of 13 over the square root of 2. You cannot be left with a radical in the denominator, so I'm going to have to rationalize this radical right here. The way I rationalize is to go ahead and multiply by the square root of 2, top and bottom. So I'm going to end up with x minus 2 is equal to plus or minus the square root of 26 all over 2. Remember right here, the square root of 2 times the square root of 2 is the square root of 4, which is just 2. So last but not least, the answer is going to be x is equal to 2 plus or minus the square root of 26 all over 2. Now, there might be some instances where they want you to write the problem all over the same denominator. If that is the case, then we are still not done with this problem. We have to take it a step further. We're going to have to rewrite 2 as 2/1 and do the same process we did before. If I have to make the 1 a 2, I have to also multiply the top by 2 to make it 4. So this answer becomes 4 plus or minus the square root of 26 all over 2. So your answer can be written either way, either as 2 plus or minus the square root of 26 all over 2, only the radical 26, or you can put it all together. Either way, both of these are correct answers. Okay, let's try a third problem on your screen. Solve x squared minus 6x equals 13. If you're feeling a little overwhelmed right now, this is a process, and the only way you're going to get better at it is to actually try problems, okay? So the beauty about watching a video is that you can always go back and rewind and watch it again. But let's go ahead and see if you can start catching on to the steps with this problem. So if you remember, step 1 is to prep. Notice I don't have any number in front of x squared besides 1, which means I don't have to worry about dividing the entire equation. That is good. That is one less thing for me to worry about. The second thing is, now in the prep phase, I want to make sure that I rewrite the problem so that I have x squared minus 6x, leave a space, and the 13 is already on the other side. Don't mess with the signs for the number 13. It is already on the right side of the equal sign. All I did was create a space because I'm going to need it to put in the number that I'm going to get when I complete the square. So that is step 1, is to prep the problem. Now that you are ready to continue, you're going to do the actual completing the square process. You are going to take b, you're going to divide it by 2, and you're going to square it. What is the b in this case? If you said -6, you are correct. So we have -6 divided by 2 squared, which is -3 squared, which is +9. You're going to take that +9 and you're going to add it to both sides. On the left-hand side, this is going to factor out as a perfect square trinomial. It always factors out as a perfect square trinomial because in this entire process of completing the square, we are purposefully basically making this happen. We are rigging the problem so that it forces it to become a perfect square trinomial. What's going to multiply to give me a positive 9? That's going to add to give me a negative 6. And that is going to be x minus 3 times x minus 3, which is x minus 3 squared. On the right-hand side, this is going to equal 22. Once you have the problem written in this form, you can use the square root property to take the square root of both sides. On the left, the radical and the square will cancel. On the right, you gotta make sure you make that plus or minus. So you're left with x minus 3 is equal to plus or minus the square root of 22. Try to see if you can simplify radical 22. Well, 22, yes, is divisible by 2, 2 times 11, but 2 is not a perfect square, 11 is not a perfect square, so in reality, I cannot simplify that radical any further, which means that I'm basically done. If I add 3 to both sides, I get x equals 3 plus or minus the square root of 22, and this is my final answer. One of the things that I want to draw your attention to is that whatever you get when you divide by 2, like in this case, negative 3, that is actually how you are going to end up factoring this problem. What do I mean? When you divide it by 2, negative 6 divided by 2, you got negative 3. When you factored, how did you factor this out as? X minus 3. Let's go ahead and take a look at the first problem that we did. The b was 4. When we did 4 divided by 2 to complete the square, we got positive 2. How did we end up factoring the problem? As x plus 2 squared. Here we have negative 6. Negative 6 divided by 2, negative 3. How did we factor out the problem? X minus 3 squared. Why am I harping on this concept that whatever you get when you divide by 2, that's how you are going to factor the left-hand side? The reason is that when you have b is an odd number, you're going to end up with fractions. And I know how much students hate fractions. And so I'm trying to help you out by telling you that whatever you get when you divide by 2, that's how it's going to factor. Let's take a look at this problem. Solve x squared plus 5x plus 1 equals 0. We want to quote unquote prep the problem first. Notice there's no number in front of x squared, which is good. I don't have to divide the entire equation, but then I do have to move that 1. So I'm going to rewrite the problem as x squared plus 5x is equal to negative 1, and I left a space. Let's go ahead and grab b. b is 5. 5 divided by 2 squared is equal to 25 over 4. 5 squared is 25, 2 squared is 4. That means that we are going to add 25 over 4 to both sides. It's okay, don't freak out. Whatever you got when you divide it by 2, which is 5 over 2, don't put it as a decimal, leave it as 5 over 2. That is exactly how the left-hand side is going to factor. You're going to write x plus, because it's positive, 5 over 2 squared. And now I have to only deal with the right-hand side. On the right-hand side, negative 1 becomes negative 1 over 1. But I have to make the 1 a 4 so that it has the same denominator as 25 over 4. If I make the bottom a 4, I also have to multiply the top by 4. So I end up with negative 4 over 4. Negative 4 plus 25 is positive 21 over 4. Okay, I know it's a lot to take in. This is one of those videos that you might have to watch more than one time because completing the square is a process. So now I'm ready to go ahead and take the square root of both sides by the square root property. The left side, the square root and the square cancel. On the right hand side, I have to put plus or minus. So I'm left with x plus 5 over 2 is equal to plus or minus the square root of 21 over the square root of 4. The good news is that the square root of 4 is exactly 2. I will not have to rationalize in this problem, which is great because it's one less thing for me to worry about. So I get plus or minus the square root of 21 all over 2. Go ahead and subtract 5 over 2 from both sides. we get negative 5 over 2 plus or minus the square root of 21 over 2. Another good news is right now they both have the same denominator. So if I had to combine these, I can just write negative 5 plus or minus the square root of 21 over 2. Which way can you leave your answer? Honestly, it depends on your teacher or on your book, because both of them are equally just as fine. So right here, this can be your answer, or this one can be your answer. They're both correct. Okay, let's try one more time. Solve x squared plus x plus 2 equal 0. Step 1, prep the problem. No number in front of x squared. No need to divide the entire equation by anything. Now I have to just move the positive 2 over. So I'm going to rewrite this problem as x squared plus x, leave a space, equals negative 2. Now we are ready to complete the square. What is b? B is going to be 1. When you don't see a number there, it's got to be 1. So I'm going to go 1 divided by 2 squared. 1 squared is 1, 2 squared is 4. We're going to add 1/4 to both sides. Now here, whatever you got when you divided by 2, that is exactly how the left-hand side is going to factor. What it's going to multiply to give you 1/4, that's going to add to give you 1/2. But you don't even need to think about that because it always works this way. Whatever you got when you divide by 2, that's exactly how you factor the problem. Then on the right-hand side, we have to do this math. Negative 2 becomes negative 2 over 1. I needed to have a denominator of 4, so I multiply by 4, and I multiply the top by 4 as well. So I'm left with negative 8 over 4 plus 1 over 4, which is negative 7 over 4. Now, by the square root property, I am ready to continue by taking the square root of both sides. On the left, the square root and the square cancel. On the right, I have to make that plus or minus. I'm left with x plus 1/2 is equal to plus or minus I radical 7 over 2. What happened? We have the square root of negative 7 over 4, which really means the square root of negative 7 over the square root of 4. Remember, when you take the square root of a negative number, you have to take out I, and the square root of 4 is just 2. So that is how we ended up with this part right here. So last but not least, all we're going to do is subtract 1/2 from both sides. And we're going to get x is equal to negative 1/2 plus or minus I radical 7 over 2, which if you want, you can rewrite all over 2. Again, luckily we have the same denominator. So negative 1 plus or minus I radical 7 over 2. Both of these answers are completely acceptable. Okay, I'm going to give you one last problem. Solve 3x squared minus 9x minus 15 equals 0. Step 1, prep the problem. Notice I will have to divide the entire equation by 3 because right now there is a 3 in front of the x squared. So let's go ahead and divide everything by 3. Everything, even the 0, but 0 divided by 3 is 0. And we're going to end up with x squared minus 3x minus 5 equals 0. Part of the prep process is to also move the 5 over to the other side. So we have x squared minus 3x, leave a space, is equal to positive 5. So we're done our step 1, which is prep. Step 2, let's go ahead and complete the square. Take b, which is negative 3, divided by 2 squared. Negative 3 squared is positive 9. 2 squared is 4. Let's go ahead and add 9 over 4 to both sides. On the left-hand side, remember that through this process, we are rigging the left-hand side so that it is a perfect square trinomial. Whatever we got when we divided by 2, that is exactly how the left-hand side is going to factor. So that becomes x minus 3 over 2 squared. On the right hand side, I have to change the 5 to 5 over 1. The 1 has to become a 4, so the 5, if I multiply by 4, has to become 20. So this becomes 29 over 4. Once I have the problem written this way, I can go ahead and apply the square root property. I'm going to take the square root of both sides. On the left, the square root and square cancel. On the right, we're going to go plus or minus. So I'm left with x minus 3 over 2 is equal to plus or minus the square root of 29 over 2, because the square root of 4 is 2. Now, the square root of 29 is not divisible by anything. It's actually a prime number, so I cannot break down that radical. I'm just going to go ahead and finish the problem by adding 3 over 2 to both sides. And finally, my answer is 3 over 2 plus or minus the square root of 29 over 2, or I can put them all over the same denominator. Once again, we're lucky we have the same denominator. So either one of these answers will be just as fine. They're both correct. If you found this to be a very confusing process, you have to just take it a step at a time. Keep watching how I do each problem so that you can start seeing a pattern. The beginning is always to prepare the problem so that you can do the step 2, which is the actual completing the square, b divided by 2 squared. Then you want to factor, but I told you whatever you get when you divide by 2, that is exactly how the problem is going to factor. From then on, it's just using the square root property to get your final answer. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.